Welcome to GRO Mathematics and Statistics lessons. Let's consider indices part 3 today, where we'll be proving the laws of indices. So let's start with proof of law number 1, the law of addition of powers. In this law, we are going to write a raised to power x in expanded form as a multiplying itself x number of times multiplied by a raised to power z in its expanded form, implying a multiplying itself z number of times. If that happens, merging both together would give you a multiplying itself z plus x plus z number of times, and that in our index notation would mean a raised to power x plus z, and the law is shown to be true. Okay, now I want you to look at this again critically. Now let's go to law number 2, the law of subtraction of powers. A raised to power x divided by a raised to power z would imply a multiplying itself x number of times divided by a multiplying itself z number of times. Take note, if in particular x, the power there, is greater than z, the power below, then it will mean x number of a's above or in the numerator will be divided by z number of a's in the denominator. What that means is that the z number of a's in the denominator would cancel an equal number of a's in the numerator. So it will cancel z number of a's in the numerator, leaving us with x minus z number of a's in the numerator, and that in our index notation will be a raised to power x minus z. So you look at that again, and please drop your comments in the section below. Okay, so let's go to law number 3, the law of zero power. This law states that a raised to power 0 is equal to 1. Anything raised to power 0 is equal to 1. So how is that true? A raised to power 0, it can be written as a raised to power x minus x. Of course, subtracting something from itself would give you 0. So a raised to power 0 can be written as a raised to power x minus x. Take note, by the second law, a raised to power x minus x can be represented as a multiplying itself x number of times divided by a multiplying itself x number of times, and of course that will give us 1. So the law is true. Now let's go to law number 4, a power of unity. A raised to power 1 will return a. Anything raised to power 1 will return itself. So how is that true? So we are going to represent 1 as x minus, in bracket, x minus 1, that is x minus 1 short of itself. So that would mean a raised to power x divided by a raised to power x minus 1. That means in expanded notation that a multiplying itself x number of times will be divided by a multiplying itself x minus 1 number of times. So x minus 1 number of times, which is lesser than x number of times, will cancel an equal amount above, and that will leave us with a. So the law is true. Now let's go to law number 5. In law number 5, power of power, what we want to do is to show that the law a raised to power x all raised to power z is equal to a raised to power x times z. So let's see. All we have to do is to write a raised to power x in expanded notation z number of times. So a raised to power x raised to power z is the same as a raised to power x multiplying itself z number of times, and that by the first law would imply a raised to power x plus x z number of times, and if you add a particular number of times, it will give you the product of the number of times and the number itself. So that is what that law is all about, and that law is true. So you look at it again and again, and I want to give a critical review. So let's go to law number 6. Law number 6. In law number 6, the law is the law of negative index. So a raised to power minus x is equal to 1 over a raised to power x. Is that true? Let's see. A raised to power minus x can be written as a raised to power 0 minus x, and by the second law of indices we can write it as a raised to power 0 divided by a raised to power x. Of course, that will mean a raised to power 0 divided by a raised to power x in this form, taking note that by the third law a raised to power 0 is equal to 1. So that returns 1 over a raised to power x, and the law is true. For the proof of law number 7, the law of shared power of product, a times b raised to power x can be written in expanded form as a times b multiplying itself x number of times. So that's a times b, a times b, a times b, a times b, x number of times, and that will mean by separation, gathering all the a's in multiplication x number of times gathering all the b's x number of times in multiplication. So that will give you in the index form a raised to power x multiplied by b raised to power x, and that gives a product of a raised to power x and b raised to power x. So the law is true. Going to the proof of law number 8, the law of shared power of quotient. A divided by b all raised to power x can be written in expanded form as a divided by b multiplying itself x number of times, and that would mean gathering all the a's x number of times in multiplication divided by gathering all the b's x number of times in multiplication. The numerator of course reduces to a raised to power x in index form notation divided by the denominator b raised to power x in index form notation, and the law is true. Let's go to law number 9. So in law number 9, we are going to be using an inductive proof where we look at the notation, what the notation actually means. What does a raised to power 1 over x mean? A raised to power 1 over x represents the only number, say c, that can multiply itself x number of times to give a. So if, for instance, my x is 2 and my a is 4, then it will mean 4 raised to power 1 over 2. What will 4 raised to power 1 over 2 mean? It means that number c, in this case the number is 2 actually. It means that number c to which that number c will multiply x number of times, in this case 2 times to give 4. So what is that number you would multiply 2 times to give 4? The number is 2. Okay, so when x is 2, as we have in our notation here, then a raised to power 1 over 2 will be equal to the square root of a. When x is 3, a raised to power 1 over 3 results, and that's what we're going to have as the cube root of a. When x is 4, a raised to power 1 over 4 will give you the fourth root of a. When x is n, then a raised to power 1 over n is what we have, and that will be represented as the nth root of a. When x is n, a raised to power 1 over n will be represented as the nth root of a. Now bringing that to law number 10 implies the second law of fractional index would now mean a raised to power z over x will be equal to a raised to power 1 over x times z. That can be done, and of course that would mean multiplying a raised to power 1 over x by itself z number of times, representing each of these as the root, the x root of a, the x root of a, the x root of a, multiplying itself z number of times. That will give you the x root of a all raised to power z, and the law is true. So I hope that video satisfies you. Please look at it again and again, and I believe you'll be satisfied. Please try to like our videos and subscribe to our YouTube channel, and we'll see you in the next class. Thank you very much.